All right, Geometry Advanced, welcome back. Sorry I can't be with you today, but up on the board you should see some of the homework solutions for the even problems from your weekend assignment. So I'll give you a minute or two to look these over before we go to the next slide. Again, remember that if there's anything that you want to talk about, please mark it, circle it, so that we can come back to it later when I return. Okay, if you need more time on these, just ask to press pause, or we can come back to them in a minute. Okay, we've got a few more homework answers up here. I know those converse, inverse, contrapositive take a while to write out, but we should have complete sentences written for me. All right, let's jump into today. We are covering section 2.3, apply deductive reasoning. So our goal or objective is to form logical arguments using deductive reasoning. For our warm-up, we are again going to write a converse, inverse, and contrapositive for this statement. If the measure of an angle is less than 90 degrees, then the angle is acute. So we need the converse, inverse, and contrapositive. So get going on writing those down. I will put up the answers in just a minute or two. All right, for our converse switches the hypothesis with the conclusion. So our converse would be if an angle is acute, then it measures less than 90 degrees. Okay, switch your hypothesis with your conclusion. The inverse does not switch them, but it negates both of the hypothesis and the conclusion. So we're not going to switch the order, we're just negating it. So if the measure of an angle is not less than 90 degrees, not less than 90. then the angle is not acute. Okay, same order as the original, we just negated both parts. The contrapositive is when we both switch it and negate it. So it's like taking the converse and negating it. So the contrapositive would be if an angle is not acute, then its measure is not less than 90 degrees. Okay. Now we got a lot of writing, so hopefully we got all those right on our first try. If we need another minute, maybe ask for a pause. Make sure we're able to do these. We're feeling confident with these. If not, we might want to practice some more. All right, let's continue on into today's notes. Sorry, too fast. All right, deductive reasoning. That's what we're using today. It is using facts, definitions, accepted properties, and the laws of logic to form a logical argument. So these are based on things that we know to be true. Based on truth. So this isn't just something that we think or our opinion or something that might be the case, something we observed. This is hard facts, things that are definitely true. All right, so those laws of logic that were mentioned at the end there, let's learn a couple of those. The first one is the law of detachment. And basically it's saying that if the hypothesis of a true conditional statement is true, then the conclusion of that statement is also true. And these are the kind of things that just make sense. So if I give you an if-then statement and you know the first part of it to be true, then the second part would also be true. A basic example of this is if the day of the week starts with M, then it's Monday. Okay, you're given that whole statement. And then I tell you, today starts with an M, you know that it must be Monday. There aren't any other options. Okay, it just kind of makes sense. Our other law of logic is the law of syllogism. The law of syllogism, if you remember the transitive property, that's something that you've talked about before, this kind of feels that way. So it's set up with 3 conditional statements. The first 2 lead you to the last one. So the first 2 are usually given to you, and then you come up with the third one, the one down at the bottom. Now these whole hypothesis P, Q, and R, those are just representing different statements. So if you're given hypothesis P, then conclusion Q. If hypothesis Q, then conclusion R. You can kind of cut out the middleman of Q. He was a conclusion of the first statement and the hypothesis of the second statement. We just kind of cut him out in both pieces, and that's how we formed our third statement. If hypothesis P, then conclusion R. So we cut out the guy in the middle to save us some time. Okay, and we'll see that in action in just a couple examples. All right, so let's get to those examples. First up, use the law of detachment to make a valid conclusion in the true situation. Okay, so the law of detachment, that first law that we looked at. If two angles have the same measure, then they are congruent. So you're given a conditional statement. Then you're given a piece of information. You know that the measure of angle A is equal to the measure of angle B. So you have to come up with a conclusion that you can draw from that. Well, that statement that they gave us, the measure of angle A equal to the measure of angle B, that's two angles that have the same measure. So that fits the hypothesis of their statement. That means that the conclusion must be true. They are congruent. So angle A is congruent to angle B. The law of detachment is usually so easy, some people make it hard. You're given a conditional statement, you're given a piece of information, you're asked to draw the logical true conclusion. The end. So let's try another one. On number 2, Jesse goes to the gym every weekday. Now that wasn't written as a conditional statement, but we could write it that way. If it is a weekday, then Jesse goes to the gym. But we are told today is Monday, so what conclusion could we draw? Hopefully you're saying that Jesse is going to the gym. Okay, he goes to the gym every weekday. If today's Monday, that makes it a weekday. Then he goes to the gym. So Jesse goes, or Jesse will go to the gym. Okay, if that doesn't make sense to you, just mark it, put a question mark by it. If it's not making a whole lot of sense, and we can talk about it when I come back, or you can ask somebody else in class about it after notes, or maybe go to tutoring and get some help on it. Okay? These are not meant to be challenging though, but sometimes they're so easy they become hard. On example 3, this time we're switching it up. We're using the law of syllogism to write a conditional statement that follows from the pair of true statements. So remember in that law of syllogism, that second law of logic, we're given the first two statements and we have to come up with the third one. So if Ron eats lunch today, then he will eat a sandwich. If Ron eats a sandwich, then he will drink a glass of milk. So we are writing an if-then statement about what's happening here. If, then. The whole idea here is to cut out the middleman, or what's in common, the overlap. So where do these statements overlap with each other? Hopefully you're seeing that they overlap where they say that he will eat a sandwich at the end of the first statement and the beginning of the second statement. Okay, both of them saying he will eat a sandwich. So we take those out, and if those are gone, then our statement would read, if Ron eats lunch today, then he will drink a glass of milk. Okay, whole idea is to cut out the middleman. We're still writing an if-then statement as our answer. So your answer should still have the if and the then in there. If they don't, it's not quite right. All right, let's move on to example 4. Use inductive reasoning to make a conjecture about the sum of a negative integer and itself. So inductive reasoning, that's what we were doing in 2.1. That's when we had to make observations or look at examples. So I am again going to want to look at a couple examples. Let's do 3 examples of this situation. And then we can come up with our conjecture. So our conjecture is supposed to be about a negative integer and itself. So we get to pick the negative integer, like -5. We're taking the sum, which means that we are adding them together. When I take -5 plus -5, I get -10. Okay? Choose another negative integer, like -8. Add it to itself. When we take -8 plus -8, we get -16. Oh, that's supposed to be example 3. Last example, let's look at -25 plus -25. And that would give us -50. So now that we've got some examples to make our observations, we can come up with a conjecture for this. Okay, our conjecture should be about the sum of a negative integer and itself. So this is where we have to really look at those examples we made and try to see if we can recognize a pattern here. Do we notice a relationship between our sums and the original integer that we worked with? Hopefully you're realizing that this sum is 2 times the negative integer. And that is our conjecture, based off of inductive reasoning. Okay, the next part of this question asks us to use deductive reasoning to show that the conjecture is true. Deductive reasoning means facts, definitions, properties that we accept to be true. Anything with evidence behind it, really. Not just general possibilities, but specific ideas that we can use. So, if we're talking about a negative integer, we cannot assign it a number for deductive reasoning, because then we're looking at examples and that's inductive. So if we just want to represent a negative integer, but we don't know what it is, what do we use in math when we don't know a number? Hopefully you're saying a variable. A variable is what we use when we don't know what the number is or what it should be. So we would represent a negative integer with a negative n. Or if you wanted, you could use a negative x. Something to show that we've got a negative number here. So if we are taking the sum of that negative integer with itself, n plus negative n. Well, we can simplify that because we took Algebra 1 and we learned how to combine like terms. So we would say that this is just negative 2n. Or if you really wanted to rewrite it even more explicitly, you could write it as 2 times negative n. Okay, either one of these really is fine. This one tells it a little more explicitly how we made it in our conjecture, 2 times the negative integer, but they mean the same thing. So when they say to use deductive reasoning to show that it's true, this is what we're talking about. This is what we would need to see. Okay, that says it's true for any number that we would plug in there. All right. Last example. What is the main difference between inductive and deductive reasoning? I'll give you a minute to answer that. All right, so I put up how I would word my answer. Yours doesn't have to match perfectly, but it should be along the same lines. The big difference here is that inductive reasoning is based on observations, just things we notice, while deductive reasoning is based on facts, things that we know to be true, that have been proven or shown or accepted somehow. Observations just mean that's what we see, it's what we think might be the case. Deductive reasoning, we can't really argue with, based on facts. All right. Your homework you should have on your assignment guide, but here it is on the board just in case. We are on page 90, 4 through 10, 16 through 18, 21 through 22, 25 through 28. Remember that tomorrow you are going to do some review work, and when I return to class on Wednesday, we are going to take a quiz. Make sure that you have all your questions that you need answered ready to go on Wednesday, or you're attending tutoring to get those questions answered while I'm gone. Come to see me Wednesday before school, something. All right.